Hello, this is the continuation of Lagvoid's first presentation video. This video is an overview of the settings in Lagvoid. For further details, please have a look to downloadable documentation. I already have created a folder that contains samples, a folder for recorded sounds, and two folders to save song settings. First, let's initialize the program by removing any files if exists from Lagvoid's folder and launch executable file. You can do this at any time as the ini file will be rebuilt with reset values. In the setup page, we assign our folders to corresponding elements: sounds, record, song 1 and song 2. Now let's set up audio. We stick to Windows MME, a driver with a big lag, perfect for demo purpose. You probably have a better driver, especially ASIO, but this example will show you the way to define settings. Signal vector should be half vector size. Signal vector set to 1 is a cause of CPU overload problem. Overdrive and scheduler should be on for MIDI clock to work properly. If you own an audio interface with multiple outputs, you can select main out here. We will leave autoplug big buffer checked. It means that big buffer will record any signal connected to main out. Okay, let's click module name. It turns green, which means it's connected to output. Now let's raise the level to the maximum value. If we go to mother page, we see that we're buffering input. That lag is annoying, so let's go back to default status by clicking the big init button. You can find big init button here too. Let's check input model for a better setting. If you have an audio interface with multiple inputs, you can set it here. We don't want to monitor input, but we want the input to be connected to big buffer, so we checked force big buffer. If you check direct out, the input will always remain connected to main out. We set input to proper level and click set init volume. This value will be recalled each time you press big init button. Let's go back to mother. Now we're buffering input without listening to it. The mainstream looper mode is the live mode. Let's try it. 1, 2, 3, 4, 1, 2, 3, 4. Again. 1, 2, 3, 4, 1, 2, 3, 4. Doesn't work because the loop comes late. To fix this, we can set Lagvoid to read a bit in advance into the buffer in the lag page. Let's set it to 200 milliseconds, which is a lot, and make a try. 1, 2, 3, 4, 1, 2, 3, 4, 1. Now it's too early. How can we find a good value? The best value depends on your system. This is a trial and error process. If you own a modern audio interface with 32 bits buffer size, you won't have to do this as lag is under perception threshold, but 10 or 20 millisecond speed up at startup can sometimes sound good. To evaluate your system's lag, a good trick is to use the player. Let's select a 8-bit hat loop. Okay, and play it in sync mode. Okay. I select 8 bits for the looper. Okay. Now let's record it through the microphone. I increase loop lag so that loop and player are synced. Okay, I set same value for mother lag and make a try. One, two, three, four, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. The lag engine allows us to play a bit with our loops for time shift effects. 1, 2, 3, 4, 1, 3, 3, 4, 2, 2, 4, 3, 1, 2, 4, 4, 2, 2. 4, 4, 1, 3, 3, 1, 1, 2, 4, 1. Okay, now let's play with MIDI. As we don't have any MIDI interface here, we stick to Ableton using virtual MIDI cable. Our virtual MIDI cable here is Loop B from Nerds. We will send Midiclock and MIDI commands to Loop B and set up Ableton to receive those commands. Let's go to Setup page and select Loop B in the Midiclock and MIDI Out drop-down menu. Now, let's have a look to Ableton. We go to Options MIDI. And check Loop B input in boxes. The yellow blink next to EXT indicates that the Ableton receives Midiclock. If we check EXT, Ableton transport command and tempo is controlled by Lagvoid. Let's set up Ableton so that M1 launches scene 1 and M2 scene 2. Okay. As it takes a couple seconds for Ableton to synchronize with incoming Midiclock, a good trick is to play first an empty scene. Let's see if player and Ableton work together. So first M1, then I play on next one. Now it's playing, and now we can listen. The player and then Ableton. Let's go to lag page. Here we can shift Midiclock just like we did with the looper, and we can do it live. We can even shift Midiclock by a rhythmic value. Audio, MIDI and lag settings are saved in the ini file and will be recalled each time you launch the program. Let's have a look at ini files. Setup, program details, and ini files with all the details from the program. Input, player, script and loop settings are saved in songs. Each song corresponds to a folder. To save what we've already done, we click Save To, then Song 1. Test 1 is now our working directory. We can have a look to the config files that have been copied to test 1. For example, let's have a look at song config. Now, let's record audio. Record checkbox triggers the recording of main out, but you can arm any flow for recording. For example, let's say we select all track, okay, and we will unselect second loop, okay, and to record, just check the box. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. We can have a look and record. Names are auto-generated. A motor-sized silent file called etalon has been generated for further edit purpose. Thank you.